Hi, I'm EJ Green. I'm grateful for the opportunity to present my paper here at the Minds Online conference. So let's start off with an example. Imagine that you're meeting your friend in a coffee shop. You're waiting for her to arrive, and then suddenly she walks through the door toward your table. Now, notice that as she moves, her global shape changes constantly. Her arms and legs swing about their joints, and moreover, her head may turn back and forth as she attempts to locate you. However, I suggest that despite these changes, there's a sense in which her overall structure seems to remain stable. I call this experiential phenomenon structure constancy. Now, what I want to first do here is to draw out the distinction between structure constancy and some of the types of geometrical constancies standardly discussed. So, let's think about shape and size constancy. These are capacities to perceive an object as retaining a geometrical property, namely either shape or size, despite changes in its distance or orientation relative to your viewpoint. Now, the important point to note about these changes, that is, the changes across which the constancies are exercised, is that they leave intact the intrinsic geometrical features of the object. Accordingly, they're usually called rigid transformations of the object. So for example, when you see a box as staying the same three-dimensional shape as it's rotated in depth, this involves treating the object as having a certain geometrical property across changes that alter its relations to your perspective. However, those changes leave the intrinsic geometry of the object the same. Now, structure constancy differs from shape and size constancy in this critical respect. Structure constancy, I propose, involves the capacity to perceive an object as retaining certain properties across non-rigid transformations. So, for example, I think that structure constancy is exhibited when you see a person swing their arms up and down, when you observe the movement of a rabbit's ears, or when you observe the rotation of the boom on a truck-mounted crane. So just to reiterate, the primary difference between structure constancy and the more familiar kinds of geometrical constancies is that the more familiar types of geometrical constancies involve perceiving an object as retaining certain properties across rigid transformations, whereas structure constancy involves perceiving an object as retaining certain properties across non-rigid transformations. So, in the paper, I address three issues in a fair amount of detail. The first issue concerns which properties are recovered during the exercise of structure constancy. The second issue concerns whether these properties actually enter into the content of phenomenal experiences, and if so, whether those experiences are genuinely perceptual experiences. Third, I ask what structure constancy might tell us about the subpersonal underpinnings of visual spatial phenomenology. So, more particularly, I ask both at what level during subpersonal visual processing does the spatial experience plausibly arise, and also what kind of representational structure might be adequate to underlie the experience of structure constancy. So I'm just going to briefly go over, in broad strokes, what I say about these three issues. So in response to the first question, I suggest that structure constancy involves the recovery of a complex property that I call compositional structure. The compositional structure of an object involves three subcomponents. First, it involves a decomposition of the object into parts. Second, it involves the part-centered locations of the boundaries between the object's parts. And third, it involves the intrinsic shapes of the parts. Let me just say a bit more about what these features entail. Part decomposition is probably the most straightforward of the three features. By a decomposition of an object into parts, I mean a decomposition of the object into a set of proper parts that together compose the object. So notice that many objects seem naturally to break down into constituents. Okay, so for example, the object at the left there seems naturally to break down into parts as I've shown at the right. Now, in accordance with this introspective observation, many psychologists have proposed that part decomposition is performed by the visual system, and moreover, that it follows certain codifiable Gestalt-like principles. So I explain this in more detail in the paper. The second feature of compositional structure is that the locations of the boundaries between connected parts are represented relative to intrinsic axes of those parts. So in other words, compositional structure involves the part-centered locations of boundaries. Now, what do I mean by this? Well, think about how you might represent the location of the shoulder joint, which forms the boundary between the upper arm and the torso. So there are two ways in which you might do that. One way would be to specify its depth and direction relative to your viewpoint. So that would be to represent its location in a viewer-centered reference frame. Another way to specify its location would be to specify where it lies relative to, say, the axis of symmetry of the torso. So that would be an intrinsic axis of one of the parts. So I suggest that compositional structure involves the locations of part boundaries as individuated in the latter way. Third, I suggest that compositional structure involves the intrinsic shapes of the object's parts. Now, more specifically, I propose that the intrinsic shapes of separate parts of an object are represented independently of one another, and moreover, they are represented independently of the shape of the whole object. Now, why is this important? Well, it enables vision to distinguish between changes that preserve intrinsic part shapes versus those changes that do not preserve intrinsic part shapes. So think again about the example in which your friend arrives to meet you for coffee and she's walking toward your table. Now, even though her global shape is changing constantly, as we mentioned, still, the parts of her body retain their shapes at least up to certain coarse-grained standards of precision. So for example, her torso, upper arm, lower arm, and so on maintain roughly the same shape across the process. So now moving to the second issue, does compositional structure enter into the contents of phenomenal experience? And if so, are those experiences perceptual? I argue that compositional structure is indeed represented in phenomenal experience, and my main argument for this claim is that changes that preserve compositional structure show up in visual experience very differently from changes that do not. So just think about the three images at the bottom. The change from the image on the left to the image in the middle preserves compositional structure, whereas the change from the image on the left to the image on the right does not. And so I argue that that contrast lends support to the hypothesis that compositional structure enters into the contents of phenomenal experience. I make this a little bit more precise through the application of a variant on Susanna Siegel's method of phenomenal contrast. I also argue that the experiences of compositional structure in question are genuinely perceptual experiences. And my primary argument here is empirical. So I call on evidence indicating that the visual system extracts each of the properties that figure in an object's compositional structure. Okay, so I call on a number of strands of empirical support for the hypothesis that the visual system recovers compositional structure. Third issue is what structure constancy might tell us about the subpersonal underpinnings of spatial phenomenology. Or more particularly, what might it tell us about the subpersonal underpinnings of shape phenomenology? Well, I argue that it tells us something very important, namely that the visual experience of spatial or shape properties in particular is partially underpinned by representations that explicitly encode both part-whole relations and represent features in a class of allocentric reference frames. The central idea here is that given that compositional structure figures in visual phenomenology, any representation adequate to underlie that phenomenology should make compositional structure explicit rather than merely leaving it implicit. Okay? So I argue that this actually raises difficulties for two types of views. Now, the first family of views that this raises difficulties for are so-called view-based accounts of shape representation that have been popular in the psychological literature on object recognition. And the main difficulty that these views face is that they don't encode any privileged decomposition of an object into parts. And so because of that, they can't distinguish between transformations that preserve the intrinsic shapes of an object's parts versus those that do not. The second family of views that I argue faces difficulties includes so-called intermediate models of visual consciousness, of the sort defended by Ray Jackendoff in his 1987 book, and also Jesse Prinz in his recent 2012 book, The Conscious Brain. So let me just say a little bit more about the second family of views. So a lot of people will be familiar with Marr's pioneering three-level analysis of visual processing. The important level from the standpoint of intermediate views is the 2.5D sketch. So the 2.5D sketch, very roughly, is a representational structure that encodes viewer-centered depth and orientation of visible surface regions. So here's a quote from Jesse Prinz. He argues that visual consciousness arises at an intermediate level, which occurs between discrete pixels and abstract models. And then later, intermediate level visual systems generate viewpoint-specific representations that are more coherent than low-level representations and less abstract than high-level representations. So I argue that by virtue of its commitment to a purely viewpoint-specific model of visual spatial phenomenology, this view faces difficulties in trying to account for structure constancy, but I explain this in much more detail in the paper. So thank you for watching this brief introduction. I hope to have a much longer discussion with you about these issues over the course of this week at the Brains blog. Thank you.